Are you new to Cisco Modeling Labs and trying to figure out what kind of system you need to run it on? Do you wonder if you need a big giant server with a lot of memory, or could you get away with using your desktop PC and running it as a VM? Today we're going to take a look at my lab, which happens to be running on a big giant server, and we're going to explore what it takes to run a lab, what you need resource-wise, and then we're going to kind of discuss ways that I could optimize this so that I could get more nodes in the lab or be more memory or CPU efficient. We'll take a look at the lab I have running now. We're going to add some more resources to it, which you can see in the upper right hand corner, and we're going to see at what point the system starts to buckle. And when I talk about buckling, I'm talking about the system running out of resources. We start getting alerts, we start seeing things turn red, orange, seeing the state of the machine maybe not being as healthy as we would like it to be to run more nodes. But we're going to talk about what it means when those things start to happen and what you need to do when you start running your labs and building out nodes and starting to see those for yourself. Now, it's not to say that you're going to see those problems. I'm specifically creating this issue because I know where the limit is of the system. I've already tested this. I've run through to see just how many nodes I could squeeze in there. But the point of this is to show you that even when it looks like I'm maxed out, I still have a little more room to add additional resources. So let's go ahead and take a look at this lab where we're running now and talk about what we're going to do with the rest of the nodes. In my lab, I have 15 VMs running. Now those are the actual routers and switches and the Ubuntu hosts that I've deployed in my lab, and they're all running right now. And if we take a look at memory and CPU utilization, we see that I'm sitting at about 20% CPU utilization and 67% memory utilization. If we take a look at the actual numbers, I'm using 84 gig of RAM, and that's all been allocated by the reservations of each of the nodes. So that's an important thing to know. When you start up a new node in Cisco Modeling Labs, there's a memory assignment attached to it. So if we take a look at the 8000V, you drag this one to the screen, and we can go to settings and we can go to compute. Now there's nothing in there, but if you click on the node itself and take a look at RAM, you can see that it says there's 4096 megabytes of RAM, and CPUs is set to 1. 4 gig of RAM will be reserved by CML when the system starts up. So if we take a look at all the nodes that I've got running, I've got 6 here, 7, 8. That's 32 gig of RAM that's been going to get reserved by Cisco Modeling Labs. If we look at the Nexus 9000V, drag this one to the screen, do the same thing, we can see that it uses 8 gig of RAM and 2 CPUs. So when we take a look at the 6 nodes that we've got running there, 8 times 6, that's another 48 gig of RAM. Like I said, with my Ubuntu host, we can actually click here and we can see that I added additional RAM. So when you change the default allocations, the data actually shows up in the node panel when you go to take a look at it. So now that we understand where the memory resources are coming from and how I've got everything assigned in my lab and what I'm using, I'm going to go ahead and clean this up, and we're going to start up the Catalyst 8000Vs that I have running right here. So let's close this panel. Let's delete these 2 devices real quick. Just right click and delete. Alright, so again, we're sitting at 84 gig of RAM. I'm going to start up 8 more 8000Vs, which again, 4 gig of RAM. That's going to add another 32 gig of resources to my CML lab. So let's go ahead and start those up. And what I'm going to do is I'm going to start the nodes, and I'm going to speed this up so that you can see the boot up process happen. You can see what the system's doing with the resources, but we don't have to sit there and wait the full 2-3 minutes for these systems to load up. And you can get an idea of what's happening in the background just at a faster speed. So let's go ahead and start them up. Alright, so we can see the system is not particularly happy right now. We started those 8000V routers, and we're sitting at a point now where memory utilization is at 93%. And we're getting this high system load warning that's telling us that launch sequencing is going to be paused until the system stabilizes. What does that mean? Well, if I try to start up some of these nodes, it's possible they're not going to actually launch. I'm going to go ahead and try to start up this Cat 8000V right here, and we've got plenty of memory left. You know, there's 116 being allocated. We've got 125 available, so I should, in theory, be able to start this node up. So let's see what happens. So we can see that there's a little gray icon indicating that it's trying to start up, but we're still getting this warning saying that, you know, everything's being paused until the system kind of stabilizes. And this is going to be what you start to notice when you're getting to the point that you're running out of resources. And it's not to say that we can't get this node to run. It's just that in the state of the system right now, there's not enough memory. There's too many other things going on. And there's no way for this node to get started. So these nodes will sit in this state, whether it's because of CPU exhaustion, whether it's memory exhaustion, or disk, and you're not going to get the node started until you've fixed one of those things, or you shut down some nodes to get some CPU and memory back. So we're going to go ahead and stop that node. I'm going to try something a little bit smaller because that's a big node. Let's see if we can get one of these Ubuntu hosts to start up real quick. So clicked on it, let's hit start, and we'll see we got the same gray icon. This is a much smaller system, not as much memory or CPU. And we're seeing the same thing. The warning's still coming up. We still have the little gray icon indicating that it's trying to start up, but it can't get it scheduled. And we'll wait a minute, but I'm pretty sure this is not going to start. So again, it's still sitting here. So I'm going to go ahead and stop it. And let's try something even smaller. Let's see if we get one of these IOSv routers to start. Again, we see the same thing. The little gray icon starts up saying it's trying to start up. It's trying to find somewhere to schedule the box to, but it's not going. And it's because the memory is just completely being sucked up by the startup of these Catalyst 8000V routers. So I'm going to stop that. And what I'm going to do is I'm going to walk away for 20-30 minutes. And I'm going to come back and I'm going to let the system kind of idle and get itself together. And we'll see if it comes to a state with all of these nodes running where we can finish booting more of these routers and switches. All right, we're back, and if we look at the lab, things are looking a lot healthier. The memory utilization is not red anymore. It has kind of come back down into more of an orange state, and we're at about 80% utilization. The little pop-up that said that, you know, memory utilization was high, you know, we needed to wait for things to stabilize before we could launch more nodes, that warning's gone. It's not popping up on a screen repetitively anymore and saying, hey, you know, I'm under pressure. So what does this mean? Well, we should be able to start up a few more nodes. We're going to try to start up the 2 Ubuntu hosts because they're pretty light, and we're also going to try to start up these IOSv routers. And we're going to see if we can get them to start up and we can get more systems to boot up. So I'm going to go ahead and do the same thing. I'm going to start all of these things up, I'm going to speed it up, and we're going to see what the system does as far as getting all these nodes up. So let's go ahead and get that done. So I'm going to click all of these nodes, and we're just going to go ahead and start them all up. Click and start. Okay, we're back, and we can see that all of the IOSv nodes started up. The Ubuntu host did not. They're sitting in a state where they just can't launch. If we come down and take a look at the little bell here, we can click on it and we see that Ubuntu 0 and 1, they're failing to find a compute host to boot the node up on. Now, it's interesting because, like I said earlier, I tested this, and clearly something is running on the system where I'm just not able to get these to boot up now. It could be that I've added something that's pushed the memory up somewhere. There's just still not enough for the system to come up. I am doing a couple different things here. I have VXLAN running. I have segment routing running. So it could be that just over time the config has pushed the memory utilization up for the systems, and I just don't have memory resources for these to boot up. There is if we look at the system, there's still 5 gig of RAM. At least one of these potentially should start up. There are some ways where we could potentially get it to start up. Maybe we jostle around what we start up, and actually I'm going to try that. I'm going to shut down this node here and see if we can get it to boot up. So we've shut that node down. That should give us a couple gig of space back. And actually we just saw the Ubuntu 0 started up and Ubuntu 1 is still thinking. Maybe it'll boot up, and it started to boot up. But let's see if I can get Catalyst 8000 V7 to start up, because it was working before. And let's see if it starts. So little gray icons there again. It's thinking about it. Let me see if I can jostle some more resources around. So, all right, so let's try turning off 2 of these IOSv nodes. Let's just see if we can get all of these nodes to start up. And the 7 node just started. So I'm going to go ahead, I'm going to start these back up. And there we go. So that's an interesting demonstration. So what I wanted to show you there is that a lot of this boils down to how resources are started up. The more memory, consuming system, the 8000V, by shutting it down, I was actually able to get those 2 Ubuntu nodes to start up. I couldn't get the 8000V to start up until I turned off some of the IOSv nodes, but as soon as I turned off 4, the 8000 started up and I was able to get the other IOSv nodes started up. So really, it's as you start to push to the end of your memory availability, it's about what you're starting up in terms of resources. It's how you order them, it's how you get those things started up. You really want to get the more memory consuming systems started up first, but sometimes you might want to start up some of the smaller nodes as you get to the end and then fire up that last big resource. The really small nodes like these IOSv routers, they started right up as soon as I fired them up, and they're only consuming 512 meg of RAM, but it's a small enough amount of RAM, but when we look at all 4 of them, it's 2 gig total, but each individual one is consuming a small amount of RAM. We were able to get everything started. What do I want you to take away from this? Well, first, I want you to know you don't have to have a giant server to run your CML node. You could get away with a VM on your desktop, but what you have to be cognizant of is what features and what nodes you're going to run in that VM. In this instance, my 128 gig is being consumed because I have a lot of Catalyst 8000Vs and the Nexus 9000Vs, and those are very memory dense systems. I could get a lot of the functionality from IOSv and IOSvl2, or even the IOL and IOL2 images, which are much less dense memory-wise. They start up a little bit faster, and you can get a lot of the things that you need from those images without running the full-blown Nexus and Catalyst images. The downside is the features that I need are only available in these 2 hosts that I'm using. So if you go ahead and you use those smaller nodes, you don't need as big of a system. But if you want features, if you have very specific things you want to run in your lab, you're going to have to run a node that has that features, has that capability, and plan accordingly. I hope this was a useful demonstration on what it takes to run nodes in CML and what the resource requirements are for when you're building out your lab. Again, I have hardware, I have a server running 128 gig of RAM. You don't have to have that. You could definitely do a VM on your desktop. I've seen people use small PCs, NUCs, things that don't have a ton of memory and run CML in those environments. Ultimately, it comes down to what features you want to run and what capabilities you need. If you're learning for CCNA or CCNP, you could definitely use the IOSv or IOSvl2 images, or even the IOL and IOL2 images. You can do all the routing, you can do spanning tree, there's a lot of features and functionality, and you can check that out in the Cisco Modeling Labs documentation, and it tells you what features and capabilities each of those nodes have. So if you have any questions, go ahead and leave a comment in the video. You can also hit me up on X or LinkedIn and ask questions there. Any questions you have about Cisco Modeling Labs, I'd love to help you out with it and help you understand what it is you might need, or how you can work around some of the limitations. Thanks for watching.